Good afternoon. On behalf of Sensive, I'd like to welcome you to this webinar, which will provide an introduction to wireless remote condition monitoring for structural and geotechnical applications. My name is Simon Brightwell. I'm the marketing director here at Sensive. But our speaker today, the main man, is my colleague Arnaud Lancon. Arnaud is an expert in the surveying and monitoring field. He's got hands-on experience of designing and supporting the remote monitoring systems above, below ground in many different corners of the world. So lots of interesting perspectives to come from Arnaud. The session this afternoon is going to run for 45 minutes. Feel free to type in questions as we go at any time, and we'll try to address these at the end. For anything we can't cover today, we will get back to you after the event. The other point to note in this introduction is that we're going to be asking you for a little bit of input yourselves. There will be some polls. We will be asking for your perspective on different aspects of the presentation as we go, and really just to get things moving a little bit on those lines, I'd actually like to start by asking you to get your fingers on your cursors, on your buzzers, and let us know what made you register for the event this afternoon. Just a little livener here, really, just to see if we can get the system working, because we will be addressing some even more important subjects than this a little bit later. We'll share the results in a moment when we've got a bit of a quorum vote on here. It's looking encouraging. I'm going to share that in a moment. Well, over to you, Arnaud. You've got a hungry audience who are very keen to learn new things today.
Excellent. Thanks a lot, Simon. I'll just pop on my camera for just a second to show everyone my lockdown face, a terrible haircut, and an awful mustache. But thanks everyone for joining, and thanks for answering the first poll. Hi to everyone that wants to learn new thing. Hi to the fans, small amount that wanted to see my face, I guess. Sorry for the ones that their boss forced you to attend, and hi to the competition that wants to learn about Sensive and how we got to the top. So hi everyone, thanks for joining, and well, let's the presentation started. So let's close the poll. Oh. So before starting, I wanted to get a few things out of the way. Quick first presentation about Sensive, very brief about who we are. So Sensive is a UK company, London-based, production and admin out of London. 90% of our personnel is within the city. We come from academic excellence out of UCL, University College of London, one of the top-rated university in the UK and in the world for research strength. We were founded in 2005, so 15 years ago, and our goal is to promote and offer wireless monitoring solutions for the civil engineering industry, and only for the civil engineering industry. So if there are a few key takeaways that you need to get from Sensive, these are the ones. Now, the second point that I wanted to get out of the way is, what is wireless remote condition monitoring? Well, first of all, when we talk about the subjects, you need a location, geotechnical, structural. That's our focus today. So either you talk about a landslide, you talk about a tunnel at some towers, you need a location that you look after, a project. Then you need a risk. If there is a risk to hurt people, or that something might cost money, you have that on your location, and that creates the need for your monitoring solution. Then we look at parameters in order to get this risk and to put some numbers on it. We will look at, for example, water levels, temperatures, 3D movements, rotation, changes in the form or shape of a structure. So all these parameters define the condition that we're looking at when we talk about the geotechnical or structural problematic. And then comes the monitoring solution. So out of the monitoring world, there are a lot of solutions available. The first one that you might recognize is well, a simple visual check. Obviously, you can record this with photography. You can do some more complicated measurements with radar. You can even use the geodetic remote sensing portfolio, or acoustic or near acoustic measurements that are more dynamic. But today we'll focus on more static structural and geotechnical sensors, the ones that you will install on sites that will provide measurements on certain parameters from your site at regular interval. So for these, you have two options. Either they can be wired or they can be wireless. Sensive promotes wireless remote condition monitoring. So the solution where the data flows through the air in a more reliable and efficient way. Once you've sorted your monitoring solution, you look at the analysis. Obviously, you can look at the raw data. You can look at the trends that it creates. And obviously, out of these trends, create some warning, create some alerts. So from the monitoring solution and from the risk, create an analysis. Finally, out of this analysis, there are some actions that need to be taken. Well, escape is the first one. Obviously, if your location, your structure might collapse, or repair, continue the work, or simply relax if everything is under control and you get continuous data proving that everything is fine. So that's what we talk about when we talk about wireless remote condition monitoring. This is this highlighted part, the green one that Sensive covers. Wireless because you get your parameter, you get your condition from your site all the way to the analysis, the end user, without any cable and continuously. That's what wireless remote condition monitoring is. Next little point that I want to cover is some key terms and concepts. Within your window, you have the ability to download some handouts wherever you have it. Feel free to download that for the rest of the presentation. This slide will be on, and it allows you to understand some terms that I will use during the presentation. So starting from the left all the way to the right, we start with sensors, external sensors. They can be done by any manufacturer, structural or geotechnical sensor manufacturers. When we talk about this, we'll think about strain gauges, piezometers, inclinometers. These external sensors can be connected to integrators. The integrators will take on these wired sensors and connect them to the network of wireless sensors that has been established. Either a mesh network, we'll come back on that later, or point-to-point network. Mesh meaning that every node, every integrator connects to each other and the data can flow through this mesh network. Or point-to-point, the network is only one connection between your node and the gateway, and the data has only one link between these 2 points. So now that we've talked about the network, we're looking at some details, the repeaters that you can have on a mesh network. Repeaters are not sensors, either external or internal. So when you look at an internal sensor, you can think about a tilt, a laser sensor that is really internal to its enclosure. A repeater will not have any sensor attached to it. It just helps the flow of data within a mesh network. From the repeater or from the nodes, you get to the gateway. In a mesh or point-to-point network, you always have a gateway, central or on the side of the project, that will retrieve the data. And from this gateway, the data will be sent to the user. Obviously, it needs to be power connected with solar options, mains option, or battery options. But the data from there will flow through cellular network, through Ethernet connection, or manually downloaded from the gateway. At this point, the data has been extracted from your project. So then you can check it, look at it, record it on a data visualization platform. So this covers all the terms that will be talked about in terms of hardware and principal concepts in its presentation. Again, these are in your handouts, so feel free to download them during the presentation or at the end. One last slide before starting the general presentation is about the networks. Within the presentation, I will mainly focus on two types of network. The mesh network represented by flat mesh within our portfolio, within the Sensive portfolio, and GEO1, a point-to-point network, LoRaWAN network. So these two key platforms, these two key networks have each other their advantage and disadvantages. So when I will present them through the case studies and through the presentation, always remember about few things. When I talk about flat mesh, when I talk about a 2.4 gigahertz mesh network, think about a spider web. That's the best way I worked it out myself, not being an expert in wireless network when I first joined Sensive. These analogies are quite helpful to understand the two platforms. So flat mesh, when you think about flat mesh, think about reactivity, think about reliability. The spider web, where you see all the points connected, allow you to have fast reporting rate, to have self-healing connection between the sensors, but will be limited by its range. You cannot stretch the spider web forever. It has a limited range, but extremely good capability of interacting between the sensors. When you look at GEO1, the analogy is the octopus. It's a slower beast, but it can extend way further. It is a powerful network. So when you look at the connection, you only have the connection between your central point, your gateway, and the node. But this connection, as you can see with the pointer, has a small bandwidth. So in terms of amount of data that will pass through this connection, it is less than in the mesh network. So again, these are just two analogies that you can reuse and keep in your head for the rest of the presentation. When you will talk about the mesh network, flat mesh network, think about the spider web, fast, reliable, reactive. When you think about GEO1 and LoRaWAN platform, think about a powerful beast, an extremely good range, but a little bit slower. This is the best advice that I can give. So finish with the key terms and quick info before the presentation. As Simon has said, the rest of the presentation is pretty simple, pretty structured. We'll look at how to select the best wireless remote condition monitoring system. First part will be how to select a reliable network. Second part, I will look at the robustness of the hardware. And final part, the precision of the measurements. What can you expect from the data? We'll finish with a quick conclusion. And as Simon said, if you have any question during the presentation, feel free to type them within the question panel. We'll answer them at the very end. So let's get started. Reliable network. How to select the correct wireless platform for your application. For this part, we'll use the case study of Monaco, Anse-du-Portier, so in southeast of France. This project is a 2.4 billion land reclamation project, and Sensive is involved with the solution monitoring adjacent structures right here, as you can see with my pointer, and right there. Here, residential structure, and there a parking lot with a road over it. So this is the case study. It's been done through our distributor GeoMesure, and in terms of size, we're talking about 40 to 50 sensors spread out the entire site. So now that you have the picture, now that you have the site, let's start with the wireless landscape. When selecting a reliable network, obviously you need to understand what's available to you in terms of wireless capabilities. Here is a list of the few options that are available on the market for geotechnical and structural application. So you might recognize some of them from just standard applications, Wi-Fi, NFC, obviously you have that on your phone, cellular as well. But when we look at structural and geotechnical application, you have to look at the limitations. For Wi-Fi, obviously that's the power consumption, that's the scalability. For cellular, that's the cost. That's again the power consumption. You have emerging technologies like Bluetooth that are reaching a really good level for this application, but they still, compared to the 2.4 gigahertz mesh or LoRaWAN, have some limitation. Bluetooth will be the range, Zigbee will be the power consumption, Sigfox will be the coverage in terms of where you can use the network. So this table quickly explains the idea of how Sensive selected the two best platforms for geotechnical and structural applications, flat mesh for the short range application, and Geo1 for long range applications. In order to look at how to select the best connectivity solution and how to select the best network for your wireless application, I've found this study from Deloitte showing the consideration for connectivity technology selection. It lists different points that everyone should be aware when selecting their platform, and that's the plan that I've used through this first part of the presentation. So as you can see, range, throughput, performance, security, strength, and maturity. These are the key points that you should look at when selecting your wireless platform. So let's start this part with a quick poll on connectivity and on network. Simon, up to you.
For this next little bit of work that we're asking you to do, we'd like to get your take. We've just seen what the consultants employed by Deloitte came up with, but what matters to you really? Is it the distance to or across the site? Is it the volume or capacity, the throughput? Is it the system performance, the technical factors? Is it the confidence in the security of the data system? Or is it the confidence in the track record and the maturity of the provider? These are things that all need to be considered. And I can see that fingers are on buzzers out there, and we've got a lot of responses coming in. And we're going to close that down when we get just a couple more and share the results. They're still coming in thick and fast, slowing down a little bit now. So I shall share that now. Arnaud, over to you. It looks like performance is important.
Yeah, performance, is a key point when selecting your wireless platform. That is true. When we look at the battery life of the system, how much data it can pass through, how flexible is also your solution and adaptable so to your different sites. So I will make sure, knowing that, to develop a little bit more this part when we come to it. But I can see that in second comes the proven track record, the maturity of the solution, and that's also a good indicator. People in our industry are quite conservative, already making the step towards wireless network and wireless innovation is already being innovative. So obviously, when you select your wireless platform, you need to make sure that you select a wireless platform that you can trust. So I'm going to hide this poll and go on with this part. So starting with range, when you look at this aspect, this factor of the wireless platform, the question is how big is your site and what could come between me and the data? That's your first consideration when you select your wireless platform. So obviously you have to understand if you're on a project that is simply one building, is that an entire construction site, several sections of a project, an entire city, or simply an open field without anything else? Are there obstructions? Will there be activity around your sensors? And finally, how will you establish the flow of data between your sensors? Through the mesh network, again, the spider web, or the point-to-point, the octopus. So to highlight that, let's look at our case study back in Monaco. Here we had distance of about 100 to 200 meters to cover, so not insanely big. In terms of obstructions, we were looking at concrete stilts just under the residential building, and the specificity of these stilts were that they had anti-corrosive structure within them. So in terms of the signal going through the structure, it made it quite challenging. We also had to consider the traffic around the site from the construction sites, obviously, but also from the adjacent road where cars were passing, standard cars most of the time, but also the Formula One Grand Prix once a year. So here, the choice has been made to select a mesh network, relying for the data to pass on network hops from the gateway, from the nodes all the way back to the gateway, in order to avoid obstructions and to cover a limited range. We didn't have to go too far. So the mesh network was the choice of the distributor and the user on this specific project. Second part and second consideration is the throughput. Question here is how much data can flow through the network? How much do you need? How much data do you need at the end? Well, then we need to look at the frequency requirement in terms of looking at how much data. Is that a safety sensitive site? Do you need to go down to under the minutes to make sure that you have meaningful data? Do you need data synchronization? All the nodes reporting at the same time? And also with upstream and downstream volume, do you need to have data, yes, coming back to you, but do you need to potentially make firmware updates because your site will have a long duration? So going back to Monaco, going on the next part, we can look as well as the throughput, as the performance. That was your selected part when it comes to selecting your wireless platform. When it comes to performance, the question is how well the system will cope through time and site changes. If the site has a long duration, what will be the battery life of your wireless system? What is the data reliability that is expected on this site? Is that something near perfect, or are you happy to miss some packets because you're just doing daily checks or hourly check that does not impact the safety? Finally, system flexibility. Do you need to have a system that will self-optimize through the length of your project, or are you happy to program that yourself? These are the key points that you need to look at when it comes to the performance. And for Monaco, there were key things that needed to be checked when it comes to these two points. First of all, the frequency requirements. It was 10 minutes on this site with the ability to go down to 1 minute if alarms were raised. Data synchronization was a must because you had to both monitor the columns at the same time as a differential settlement on the structure. Upstream and downstream volume, the site was planned to be a multi-year site, at least 3 years. So we need to make sure that the system will allow updates of the system when it comes to it. Project duration, as I said, was several years. So we need to make sure that the battery life would cope. And system reliance, the system reliance had to evolve with the site. At first, there was nothing on the structure, but then you had site activity. You have the Grand Prix coming on once a year. So you need to make sure that the system could adapt to these events. Finally, system flexibility. Was the system scalable enough? Yes, the system only started within this tunnel, the Formula One Grand Prix tunnel, but then moved on as well to a parking, as I said earlier, not too far from it. So the ability to add nodes was quite important. Next part on choosing your wireless system, next key point is the security. How can the environment impact my network? And is my data well protected from extraction or meddling? So when you look at that, obviously you need to check the network robustness. Are you able to continue to process data and get data within a tough RF environment or with other network interference? And is my data protected with some sort of encryption? So these are key points that comes up when you look at the security of your wireless system. And for this case study, we're looking at the strengths first. On top of security, you need to look at how trusted your system is in terms of, is the technology widely supported in the industry? Has it been accepted by the industry? That's the sort of acceptance point. So on top of being secure, has it been accepted by key authorities, key player in your industry? Then you have to look as well at the industry leadership. Not only it has been accepted, but is it bringing something new to the project? So going back to Monaco, in terms of security, obviously the network needs to be robust there. Monaco has a very busy RF environment. It's an extremely dense city with a lot of things happening there. So the system, the wireless system, was robust enough to continue to work in this environment. Protected network, again, the data had to be protected for the end users. It is confidential data for the building owner, but also for 9 other different actors there. So we need to make sure that through encryption, through different protection of the data within the mesh network, the data was not going out and was not meddled with. Finally, in terms of acceptance, this project trusted the 2.4 GHz mesh network because at this time, it has already been used on projects like Crossrail. It had Network Rail approval, London Underground approval, and that was back in 2017. So as you can see, the client was already trusted and established technology at the time. Finally, when we look at the industry leadership and the strength of this wireless platform, obviously you need to look at the wireless itself, but how it is supported. There, the project had the help of not only the user, local surveyor, but also a distributor, regional distributor, GeoMesure, and Sensiv in the background, making sure that everything was going smoothly technically. Final point when it comes to selecting your technology, your wireless technology and your wireless network, looking at the maturity. We brushed on that a little bit with the strength, but focusing on this technology, how stable is your wireless platform? Is the technology stable enough with multiple devices on its own? Has it been proved through the years? So through long-term testing, through integration of internal development and external compatibility, and can you trust its established partners to help you through your project? Going back to Monaco and highlighting these points, the installation, as I said, was back in June 2017. The project is still ongoing. So in terms of proving the reliability of the system of the wireless platform, these 3 years are approved for themselves. But through the years before the acceptance of the system, it had been 12 years already that Sensiv had been established and that the mesh platform had followed continuous improvement. In terms of sensor integration, to give you an idea, at this stage, we had already integrated our nano portfolio, nano tilt sensors, and laser optical displacement sensors. So when looking at the maturity of the platform, it's important to note that we're already integrating multiple sensors. In terms of proven case studies, well, we already had key partners in the geomatic world, like GeoMesure in France. And not only this project worked for 3 years, but it continues to bring success to the user that are GeoMesure, the regional surveyor, and Bouygues Travaux Publics on top of this project. So that concludes the first part. Jumping on the next one, the robust hardware. So we've looked at, when it comes to wireless remote condition monitoring, you need a reliable platform. How can you do it? We've looked at the different points. Now the question is how to select equipment design for your industry requirement. The case study for this part will be in New Zealand, Highway 94 landslip, and we will start this part again with a quick poll.
So for this next little exercise for you, we'd like you to think about the most important factors when you're considering the monitoring hardware. What factors are the most important? Is it the robustness of the system, the ruggedness, the ability to perform in harsh conditions, the ability to work remotely across long distances, flexibility perhaps, the ability to configure with different systems and deploy in lots of different places. Again, lots of feedback I can see coming in here. I'm going to close this one fairly quickly because our time scale is tight today. It looks like a fairly even spread, so I'll share that for you to consider, Arnaud.
Yeah, and I'm happy to see robustness. Obviously, quite a tight poll, but yeah, robustness is a key element when it comes to the structural and geotechnical environment. Obviously, you need to have a sensor remote and the ability to install it anywhere. The flexibility of adapt your hardware to any conditions, but the robustness is really key when it comes to looking at, will my solution continue to work within my environment, and has it been designed for this specific environment? So let's hide the poll and continue to this part. So let's look at the first aspect of how to select your wireless condition monitoring hardware. And the first question that you need to ask yourself is how well your hardware will resist the harsh environment, how robust it is, as Simon said. So when you come to that, you look at the sealing effectiveness. That's quite important. Is your sensor waterproof? What sort of IP rating are you looking at when it comes to this specific piece of equipment? Do you have to open the enclosure to perform simple tasks like configuration? Do you need to open it on site, or are you able to simply remotely work your hardware? The enclosure quality itself is also very important in terms of material. Obviously, you need to look at the different options that are there, but is it impact resistance? Do you have the possibility to have antenna protections, for example? This sort of add-on that makes your product even more robust. So when we go to New Zealand, obviously on this site, we had some of the harshest conditions that you can find around the world. When we look at the sealing effectiveness, well, there we have freezing temperature, hot and dusty summer. When it comes to the enclosure quality, you can expect rock impacts. Obviously, we're on a landslide, but as well as the Kia birds that you can see on the right here. This was not expected at the start, but this bird sort of proved the quality of the equipment up there and the necessity to have robust hardware, because for the ones that don't know Kia birds, they will attack any sort of electronics, plastic that they can find in this area of the world. You can see one attacking a car antenna, and that would be the same for any electronic sensors that we'll find there. So as a proof of success for sensitive sensors and for the distributor, it was good to see that the system continued to work even facing these ferocious birds. The next point when you look at the quality of your hardware, how robust is your hardware, is as well how remote it is. How does it adapt to environments that are far away from cities or that are simply difficult to access? Obviously, on this specific case in New Zealand, it is far away from any civilization, but you have cases in the middle of the city where you cannot go check on your sensors, you cannot go out there for maintenance. So here, the remote aspect is key. So the key question for this part is, can your hardware be reliably installed in a wild or difficult access? When you look at that, you need to consider the battery life. Obviously, can it stay there for a long time? You need to look at how flexible the communication is. As we said, the mesh network or the point-to-point network make it very easy for the sensors to communicate back to a central point. But after that, do you have the ability to connect to a satellite link, a radio link, or to create what we call monitoring or telemetry hub in a tunnel environment, for example, to extract the data through an Ethernet connection? Then you need to be able to check on the health status of your hardware. Is your hardware continuously working well? And that's through system status, obviously, but also by performing firmware upgrade to always continuously improve your system. So going back in New Zealand, when we look at the remote aspect of the technology and this consideration, well, obviously, being in New Zealand, being in this part of the New Zealand, it had to last for several years. So in terms of low power, the system has to use low energy computing for communication and readings. The system that you select for such a project also need flexible communications, as I said. So in this specific case, the client, the customer, had used a VHF radio link from the gateway, linking back to the base camp at the end of the valley. And finally, in terms of health check, this radio link was giving the ability to everyone to check that if the sensors were damaged or stopped working for any reason. It didn't happen, but obviously if you have to keep this site safe for the traffic and the people working under, you need to make sure that it continuously works with some alerts, system alerts put in place. Going on to the final consideration when it comes to the robustness of the hardware, is your hardware flexible enough? The question here is, how complex is your hardware to install, to use, or to manage? It needs to be as simple as possible in all these cases. So when we look at the points, first point is your system a turnkey solution? Can it be self-configured? Can you remotely change parameters? Can you perform an easy installation when it comes to things like orientation limitation of a tilt sensor, for example? Do you have a limited range of installation for your hardware? The answer is try to select the solution that has as little limitation as possible. Finally, for fleet management, obviously you need a scalable network and you need the ability to redeploy the system over and over. So going back to New Zealand, when we look at the system and when it comes to the fact of being a turnkey solution, well, here both the distributors, position partner, and the user didn't need to open the nodes on site, didn't need to open the enclosure, didn't need to have an advanced degree in coding to perform the configuration. At the end, they just brought the solution to site, installed it, and it was an easy installation. It had to, because people had to repel from an helicopter to access the most dangerous points. So when you have to do it right, you need to make sure that it's as easy to install as possible. You don't want to be up there leveling your node to make sure that it's between 10 and 15 degrees to make sure that you have the right data. Finally, fleet management. Again, mentioning our distributor there, it can be fully remotely managed on the project, but also if the customer wants to move it from one slide, one project to another through the help of the client itself being able to do it with the distributor support and Sensiv support in the background. So that finishes the hardware part. This picture shows the 800 meters of the landslide that is this project. In terms of sensor up there, we have, as I said, tilt sensors on this landslide part down there. We have crack sensors on rocks, falling rocks on this specific block up here and up here, and tilt sensors attached to similar blocks to make sure that they don't fall onto the traffic, the road down there, and the people working on the landslide down there. It's been installed in March 2017, and again, it's still an ongoing site that didn't need maintenance, that didn't need replacement, that is a success for the robustness of the hardware. Let's move on to the third and last part. This part is about precise measurements. So now we've checked the box of having a reliable network. We're checking the box of selecting a quality, robust hardware. The final part is to look at the measurements. How good are the measurements is the data that you extract from the solution. How to select the best data available to reduce risk on your project. So for this specific part, we're looking at a third case study in France, the SNCF line 140 from Reading to Metz. And there the project was a piling project. This line was built in 1877, so quite old. Obviously, it has gone through many work, but some work there was needed around different culverts, and the embankment had shown some instability. So that's the background for this part, looking at precise data. Let's start this section with a quick poll. Simon, up to you.
Okay, last time around for this, and what we're considering here, again, in the context of the measurements themselves, as Arnaud says, what is the critical factor? Appreciate these things are all important. The stability, is the reading affected by the environment, by the weather, for example? The intelligence, is the measurement able to trigger an action? Can a movement sensor trigger a camera, for example? Or the flexibility, can you integrate it with existing or future systems even? So all of these things are important. It's a difficult choice, but you've got to choose one. And I can see that a lot of people are scratching their heads and coming up with answers, and I'm going to close that any second now and share the results for Arnaud. Still a few more coming in, just slowing down, so I'm going to share that.
Excellent. Thanks a lot, Simon. So stability is the winner with this part. And that's true. Stability is the basis of all what follows. When Simon mentioned intelligent and smart triggering, it is a key part and it is useful. Flexibility and the ability to integrate within different platforms and within an existing portfolio is very useful as well. But stability, at least to me, is the starting building block when you look at data, because the less noisy your measurements will be, the better your components will be. Obviously, the rest should follow if you have the appropriate platform. So let's move to the slides and let's move to the part and try to highlight each and every section that we've just talked about. So starting with the stability, the question when looking at stability is, regardless of the environment, how repeatable will your measurements be? It doesn't matter if you're in the Australian desert, it doesn't matter if you're on a railway in France or at the top of Scandinavia in a freezing environment. At the end of the day, you need stable data. You need to avoid noisy data to take the right decisions. So when it comes to that, it needs to be completely independent from the environment. You need to be able to trust your raw data when it comes to wireless remote condition monitoring. And you need to avoid as much as possible compensation, this sort of extra calculation that add a layer of, yes, uncertainty. It's great if you can filter, put a median on maybe temperature fluctuation, but it's even better if your component gives you already stable and repeatable data. So when it comes to choosing your components, you have a choice to make. quality or low cost. It's hard to find one that does both. And when it comes to the approach of data, you don't have to think only about this one project, this one cost that you'll have upfront, but think about the total cost of ownership. You might invest a little more in more precise data, in better measurements, but remember that you'll be able to use, because of robust hardware that we've talked about before, you'll be able to reuse this better product over and over and over without being impacted by time or conditions. So that's stability. And going to France to look at what was done in Mittersheim, that's the name of the small village next to this project. So when it comes to being environment independent, well, not sure if it's clear enough on the picture, but during the installation, this specific installation, for example, it was snowing. Not ideal during French winter. It's not uncommon. The tilt sensors that had been selected and the wireless system that had been selected, when they compare to an optical solution, or when they compare to maybe a lower quality type of sensor, deliver stability of readings for the cant, the twist measurements, and the longitudinal profile of the railway, of the track geometry. When it comes to the choice of sensor, yes, the end user, the railway authority or distributor could have chosen a cheaper product. But in the end, they were also fully aware that this system will not only be used on this railway, but could be reused over and over on any project coming after that. So starting with great data, they were also able to justify a slightly higher cost, a better quality of equipment through the many projects that came after that. Looking at the data and how to select the most precise data, you also have to look at how intelligent is your data. Not sure if that's really clear, but the question here is, what is your system ability to process meaningful information and speed up the decision process? How can you use the data in the most efficient way? And is your solution, does your solution allow you to do that? So when it comes to the intelligence of the data, we first look at the possibility of things like adaptive reporting rate. Can you remotely change this reporting rate? That's something that you should be able to do with a wireless platform with wireless remote conditioning sensors. But can it also perform automated changes? Does that mean that a tilt by itself locally can increase its reporting rate if it breaches a trigger without having anyone clicking on a button, raising his reporting rate, or connecting to a platform? Can it implement smart triggering? If a tilt sensor detects a movement, can it send an information through the network to trigger group readings of a group of sensors around him? That's something that the mesh network does really well. And cross-sensor integration, Simon hinted at it during the questions. Is a sensor able to trigger a different type of sensor? When you look at it, a camera, for example, a tilt sensor passing a certain threshold can trigger an image, a picture, and give you the information of what's happening on site. Finally, and more simply, is your system, is your data, does it allow you to perform remote calculation and alerts from stable raw data, from quality raw data? Are you able to translate that in engineering units easily? Are you able to send text and email alerts? And are you able to deliver this data through different levels? An end user that just wants to see graphs, or an end user that wants to receive certain level of alerts, depending on their position in the decision chain. Going back to France, here is an example of data that was measured on this specific site. So here you can see two graphs. Top graph gives you the cant, so the difference of height between two rails, and then the twist of the track through the project on a specific location. So here, what's interesting is not only the stability, well, the precision of the data, but how it can be managed. You can see here different trigger levels that have been implemented by the end user. And you can also see, if you zoom in, I think you can also see a difference between this part of the reading and the part that follows just after. Going back with the laser pointer here, you can see that the frequency increase. So not only you have quality data, but here in terms of processing the information, the client was able to increase the reporting rate, get more information when the first trigger was breached, making sure that everyone was safe on site and the traffic could continue without any problem. This specific movement happened when they started the sheet piling 3 meters away from this area. So it's extremely efficient, immediate, and gives information that helps the decision quite quickly. Final part of choosing precise data is the integration. When you look at the data, it's great to have good quality data. It's great to know that you can process them in different ways that they can help your decision. But it's also very important that they can integrate within your existing portfolio or with other third-party applications or solutions. So when it comes to that, you need to look at how user-friendly your data is. Can you use it with your existing expertise? Is it easy enough to interpret through a platform, through graphs? And do you allow collaboration between multi-users when looking at the specific data? Finally, are you able to use this data on multiple platforms? Sensive has offer one to its clients, but we are a system agnostic company. So when it comes to geomatic distributors, when it comes to monitoring experts, they have the ability to export the raw data quite easily through FTP, through API transfer, or even simply manually export the data to their system. Going back to France, coming back to the case study, here, this example of integration is very true for several reasons. First of all, when we look at the user friendliness of the data, it is true because not only experts were checking out what was happening in terms of track geometry, but also people that were simply, well, the technicians, the engineers doing the sheet piling next to the railway. They had to be able to look at graphs, to look at others from their cell phone while working 3 meters away from the track. So the user friendliness was key on this project. Multi-platform, as I said, different distributors or different users will already have their platform. GeoMesure, for example, use the Trimble 4D platform from Trimble. They have the ability through an API connection, through an API structure, to extract the data from the site and compare it with other types of data. So it's quite key to understand that, not only when you select your wireless condition remote monitoring platform and solution, you want to be able to look at it yourself, but you need to understand who else will look at the data and how open your solution is to the world. That's it. That's finished for the 3 parts and the 3 key points when it comes to selecting your wireless remote conditioning platform. So in order to finish this, 2 last slides. The first one is to quickly go through what Sensive goal and what we can offer to select this this platform, this wireless solution. The idea is that we combine reliable, robust, and precise these 3 aspects that I presented because it's simply our motto. That's what made the company when we started 15 years ago to work on wireless remote condition monitoring technology. And every aspect has been a key part in the design, in the creation of our solution. So not only we can provide solution for the monitoring experts, for top surveying companies, but we can also help through ease of access, through solution, the local land surveyors, the local engineers that may be not familiar with the wireless technology. We make it easy for them to use. And that's true from projects that are 1,000 nodes on high-speed 2, for example, here in the UK, to a handful of sensors in Katoomba, Australia, on their scenic railway, where we're monitoring the movement of a scenic point, just on this extreme part of Australia. So no matter the scale, no matter the client, we make it easy for you to use this solution and to get the information you want when it comes to monitoring. As a conclusion, I think it's important to note that this presentation shows you obviously how to select the best solution, what key points you need to consider, but that whoever or wherever you select this best solution, you need to remember that the technologies that you will select, remote, wireless or not, sensitive or not, there is no silver bullet to your problem. There is not one solution to answer your questions. Why? Well, that's because the solution, wireless or not, can help you to predict what happened. That's the first thing. But that you could do with a visual approach. Has it collapsed or not? Is there a crack or not? A solution can now help you to understand why it happened. That's great. Looking at continuous data, you can see the evolution of a trend. You can see the changes of behavior of a structure. You can now also understand what potentially will happen, be predictive. And when you look at solutions like Sensive, when it comes to customers that use our product, they have the ability to look at seasonal changes. They have the ability to understand what's a daily fluctuation versus a normal trend. So you can be predictive in trying to understand what will happen. This solution can help you to do that. But when it comes to what action needs to be taken, this is down to the client. This is down to the user. Whatever good solution you have, whatever a wireless platform you might be using, however robust your hardware is, at the end of the day, the key part of this system is the human part. And you need to understand the data. The human factor will never be avoided within this solution, within the monitoring solution. And always, you always have remember whenever you select this solution that this is always the missing link when it comes to difference between a successful project or potential risk or potential failure. So this was the last point that I want to make. Thanks a lot for listening to this presentation. I will look quickly at the questions with Simon, but yeah, thanks again for joining today. So let's go to the panel. Simon, have you spotted already a couple of questions that seem interesting?
Yeah. There's quite a few that have come in here, and we're not going to cover all of these now. I apologize in advance, but we will respond personally to these. Now, there's a couple of ones that I would pull out that I think of general interest. For example, Arnaud, we have, do you need to survey to support or verify the vertical movement?
So that's, yeah, again, going back to sort of the conclusion and the part around choosing and selecting precise data. Obviously, when it comes to the wireless solution, it allows you to check many parameters, but in the same way, an optical solution or radar or visual inspection will detect some things. It's always recommended to have a backup. So when it comes to settlement, as the person mentioned here, it is important to always have a second solution to compare relative measurements that you might have through chain calculations or through rotation calculations, and being able to compare them to absolute movement through 3D. If we take the example of the railway in Mittersheim, the last case study, yeah, that's exactly what happened. They took an absolute reading of the sensors when installing them, and after that, during the 3 months of work, they didn't need to go. They didn't need to send back a surveyor. Sensive system was able to give the twist, the longitudinal profile. But if a large trigger had been breached, part of the action plan was to send someone to double check the absolute movement. That would be the same for a total station. If some prisms are showing very strange measurements, automated or manual, it is always good practice to send a second team, a second check, to make sure that the data is valid and that you can take the actions appropriate.
Okay, Arnaud, thank you for that. Can we fire through a couple of these fairly quickly? This one is, I think, a very quick one. Are you able to monitor longitudinal settlement of railway tracks?
So that's I guess that's related to the previous one. So as I said before, our solution, yes, will allow to measure trends and deformation of the railway tracks. As I said, the good practice is always to back it up with a manual first survey that will give you the ability to go back. But when it comes to these SNCF projects or multiple network rail projects, one project that we just won in the US with BNSF, the idea is that yes, you can look at differential settlements with tilt sensors attached to the ties, attached to the rail, and check deformation, large scale deformation in some areas.
Okay, thank you. I think I can take the next one from Kevin. Is there going to be a follow-up webinar on more technical questions and queries? Yes, the intention is that we will be having more focused events in the future, and we will be contacting you with a little survey after this to see what areas are likely to be of most interest. Daniel is asking, Arnaud, I think you'll be able to answer this one. What installations do you have in North America? Obviously quite a lot, but there are.
I think we will be here the rest. Yeah, we will be the rest of the afternoon to this demo. I mean, in North America, it's mainly in infrastructure, railway. We have a lot of geotechnical applications also with our partners, Geo Instruments. So this is a rough explanation on what we cover. Starting now to hedge towards mining as well in Canada, but at the moment, looking more so at infrastructure, geotechnical, and this type of projects.
Okay. You mentioned, this is from Peter, you say that the tilts are reusable. How old does your system need to be before it cannot be reused? What is the life of the units, of the tilts?
It will really depend on your project. I guess we have different cases of projects where you have the ability to replace the sensors whenever they come back to stock. So let's say you have several projects of few months. Well, then whenever they come back, you might consider replacing them only because, well, there might be a new version of the product or some upgrades in terms of hardware. But when it comes to a long-term project, we have some example of projects that have been out there for more than 8 years. And they continue to work. Without the need of replacement or maintenance. Thinking about one project specifically in the Netherlands, the Botlek Tunnel, the client and the user have signed up for the next 20 years with our solution. So I believe there will be one swap plan of technology, but the sensors have been installed to remain there at a certain reporting rate for the entirety of the project.
I think this is one that needs to be just clarified. From Spain, is it possible to connect your GeoWAN tilt meters to a LoRaWAN network? So, it's just a matter of terminology, really, isn't it?
Yeah, so we're looking at options. I'm guessing you refer to public network, and yes, we've looked at these possibilities at the moment. I believe in the Netherlands. Most of our projects right now are connected to our own GeoWAN gateways to make sure that you get the maximum throughput through your gateways, and that you have the full control of the gateway, so no one takes it away or takes away a connecting point on the project when it comes to it. But yes, we have looked at this possibility to connect to public networks around the globe.
Okay, I think that we probably need to close it off really now in respect of the time scale. We've gone over by 4 minutes now, but there's a question here, maybe the last one, could just be a yes or no one from you really. This is from Daniel. Are the systems integrated into a railroad signal system to automatically stop approaching trains such as PTC?
No, they're not automatically directly attached to it, and I think that's actually a choice. I guess you could always make automated decisions, always make it more automated. But when it comes to rail deformation, track geometry, earthworks movement, the reality is, and as I said in my conclusion, it's always good, it's always a good idea, good practice to have someone overseeing the data. Because when it comes to closing traffic, when it comes to stopping a train, yes, you can take very quick decisions by looking at camera pictures, like on our Barnhurst case study. The tilt sensors monitored landslide movement, picked up that few trees were falling down in the middle of the railway. The camera took some pictures and someone took the decision to stop the traffic in the middle of the night. If something like that is automated, you always have the risk that a trend could be a false reading. There is always risk of data that could be misinterpreted. So I think the human factor always needs to be somewhere in the decision chain. That was a long answer for yes or no, but at the moment, no, it's not automatically linked to signal. There's always a human factor looking at the data, and these are our customers, monitoring experts, railway authorities, people that actually understand their structure, their environment, and the data that they're looking at.
Okay, thank you, Arnaud. I think it's probably time that we brought proceedings to a close now. We have gone just a little bit over our time. So on behalf of the team here, I would really like to thank everybody who's joined us today. Hopefully it's been a useful exercise. Hopefully it's been of interest and there's been something in there for everybody. As we were saying, we do intend to hold further events like this and to focus on particular areas of application or areas of the technology. And really, we're very interested to hear what people want to hear about in those more detailed events. So there will be a little email that comes out to follow this up, and you will get the opportunity to give feedback in that. So we would welcome that, and we will use it to steer the direction of future events. So from my part, thank you very much for attending. I guess it's a au revoir from you, Arnaud.
Yeah, and thanks a lot, merci. And yes, speak to you soon if you have any questions about your solutions, if you have any project opportunities, obviously feel free to contact us, contact the business development team. We're looking forward to hear back from you. Thanks a lot.